Multi-cloud is a familiar evolution of a recurring problem in IT. Originally, we had physical servers, storage arrays, network devices that made managing a data center extremely complex. So we added a layer of abstraction called virtualization. It made it a lot easier to automate. And when we automated, this created the software-defined data center and infrastructure as a service. So with on-demand self-service, infrastructure as a service evolved into a cloud. Now with increased cloud consumption, this complexity is back. IT operations has to understand multiple cloud providers and manage them in different ways. And developers must understand the intricacies of each cloud provider they're going to build an application for. So the next layer of abstraction is here. VMware CrossCloud Services allows you to build, run, manage, and secure your applications in any cloud in the same way. Each of these services provides standardization across clouds, helping you consume clouds more easily, respond to customer needs, and to release software faster. So now that we understand how standardization can reduce multi-cloud complexity, let's look at a specific example as to how we can solve for this. To do so, let's answer the question, how can we remove roadblocks that prevent developers from releasing software to the cloud faster? And the answer is a DevSecOps practice and toolchain that gives developers the ability to build, deploy, test, and run applications in any cloud provider in the same way. And the solution is the Tonzu application platform. Developers can iterate on their code quickly without having to interface with the underlying cloud infrastructure, which dramatically increases developer velocity. So let's check it out. To see how this works, I invite my colleague Ryan Baker to give us a short demo.
Thanks, Amanda. Let's hop into the Tonzu application platform and see how it can alleviate the developer toil that's typically associated with developing applications across multiple cloud platforms and multiple Kubernetes providers, ultimately leading to getting from source code to production quicker and with fewer roadblocks. Before jumping in, let's take a look at how we clearly define the roles of developers and operators to enable collaboration instead of stepping on each other's toes by defining an inner loop for developers and an outer loop for operators. Let's focus on an inner loop first to illustrate how developers are abstracted from both Kubernetes and the cloud providers that they are working on. To get started on a new application, developers can use the Tonzu Applications Platform's Application Accelerator to choose a starting template for their application from a wide variety of application and language types. While VMware provides several accelerators out of box, your organization can create or customize these as you see fit to incorporate your best practices and architectures. Once a developer has selected their accelerator, they can start developing. From within the developer's IDE, the Tonzu application platform allows the developer to iterate and debug by allowing live deployments of their application to a cloud-based personal development Kubernetes cluster. This cluster can mimic a production cluster, minimizing the differences between the two. Here, we can see that we have launched our application using the Tonzu application platform's live update plugin, which has been built and deployed the application to our developer's personal cluster. Notice that the developer never had to worry about what cloud provider that it was running on, or any of the quote-unquote wall of YAML configuration typically associated with getting an application up and running. This allows your developer to focus on driving business value to your company through your application development instead of through configuration. Once the developer has completed development, we now focus on the outer loop. The Tonzu application platform can deploy to any Kubernetes cluster on any cloud based on your organization's pre-approved path to production, helping remove roadblocks typically associated with application deployment. Here, you can see that we have created our workload using the source code from the developer, and the Tonzu application platform has ran an integration test, scanned the source code for vulnerabilities, built and signed a container for the application, scanned the resulting container for vulnerabilities, generated the deployment configuration, and deployed the application, all with minimal involvement from both developers and operators. Notice again, the process was completely abstracted from both the cloud and Kubernetes provider that the application was deployed to. So there you have it. We've demonstrated how the Tonzu application platform can alleviate developer toil of dealing with multiple cloud environments and increase developer productivity. Back to you, Amanda.
So your developers are moving faster, creating solutions that address customer needs, and bringing new ideas to life that is driving organizations' growth. But all this has to run somewhere, right? 95% of new applications run on Kubernetes, and Kubernetes sprawl is real. It's very likely that your organization has multiple Kubernetes clusters across many clouds, including the edge. So how do we simplify this to give your operators the ability to manage, monitor, and secure Kubernetes clusters anywhere? And we provide that solution with Tonzu for Kubernetes Operations. Tonzu for Kubernetes Operations has three main components. First is Tonzu Mission Control. This is a SaaS solution that provides your administrators with a single interface for governance, lifecycle management, and to apply IT policies to your Kubernetes clusters running in any cloud environment. Tonzu Mission Control supports the VMware distribution Tonzu Kubernetes Grid, in addition to other distros and services like OpenShift, AKS, EKS, and more. Tonzu Observability ingests data from your Kubernetes infrastructure to simplify day two operations and to make it easier to identify issues. And last, Tonzu Service Mesh is a key component for a zero trust architecture and provides end-to-end encryption for your microservices. So I invite my colleague Boskey Savla to give us a quick demo to show us how this works.
Thank you, Amanda. Let's take a look at VMware Tonzu for Kubernetes Operations. Tonzu for Kubernetes Operations is a solution that will help you build, manage, secure Kubernetes clusters across different cloud infrastructure endpoints. On day zero, it will help you build consistent Kubernetes clusters across multiple cloud environments with the right kind of drivers needed to bring up the Kubernetes API, bringing in operational efficiency. Day two, it will provide you with the ability to provision policies and kind of achieve some guardrail against what kind of applications get provisioned using the Kubernetes API. You can apply policies of encryption across all the different microservices that are created within those Kubernetes clusters. In day three and beyond, it gives you the ability to centrally monitor all the metrics that are being generated, not just from your applications deployed within that cluster, but also from the cluster itself. So it gives you a visibility from application all the way down to infrastructure. At the same time, you can upgrade your Kubernetes clusters when the next update is available automatically. Tonzu Mission Control gives you the ability to see all the clusters in a single pane of glass. You can start provisioning Kubernetes clusters using Tonzu Mission Control and Kubernetes Grid to a given cloud provider that you have already added. Once you have the clusters created on a day one basis, you can secure those clusters by providing access, image, network security, and quota policies using Tonzu Mission Control. This can be done to a fleet of clusters using something called as cluster groups or workspaces. Once you have your clusters and development teams deploying applications, you can centrally monitor every cluster all the way to the infrastructure using Tonzu Observability. You can also add mutual TLS by default to all the services that get created on these clusters and applications using Tonzu Service Mesh. Finally, you can create backups and upgrade a cluster when required or when a patch is made available using Tonzu Mission Control. Thank you, and back to you, Amanda.
This is what reducing complexity in a multi-cloud era looks like. Your developers deploy applications faster. Your operators have the ability to manage, secure, and observe Kubernetes in any cloud. And your business runs at a sustainable cost.